do so. Let me try to start with the presentation. So can you see the slide deck?
Yeah, sir.
Okay, cool. So the audience that is attending, yeah, uh, we have a question already. Motivated throughout this journey most. Okay. So yeah, I'll come to that. So first of all, I would like to know like which year generally most people are from in this crowd.
Sir,
So second year.
Okay. Okay.
So mostly from second year and others are also present.
Okay. That's good to know. Then mostly probably a lot of them are beginners or who are just starting. Cool. So let's first go through these. We'll come back to all the questions. Just keep posting in the chat group. So this is roughly what we are trying. We will try to cover in next 1 hour or so. So there are generally few different stages of a programmer, and uh, we will cover the beginner, intermediate ones, so advanced ones. You don't really need to attend the session, so we'll skip that part. The we'll talk about different contests that happens in competitive programming. Uh, there are few of different types, and then team we will talk about the team contest. So just pause anytime, just paste the question in between the slides. I'll just keep on doing to and fro between the tabs. So who are beginners in programming? So if you see, if you think like Hacker Cup is actually a hacking Facebook hacking accounts contest, yes, Arjun. Do you want to ask any question or uh, probably just raise hand? So like if you think C plus is a language, then you are a beginner. So how to generally start in such a situation? You still love trees, you feel those are green, but as you grow in a programming world, you start hating trees more and more, which is a funny thing. And you have recently signed up for any of these websites. Probably the motivation comes whenever the college tech fest starts. That's when you start to know about all these things and start to build your base. So how should you generally start if you are a complete beginner? So choosing one language is super important initially. It becomes less and less important as you grow in your programming career as well as in industry. So at first, your most scariest thing is how to translate your thoughts into code, which can be understood by the machine. So fix one language. Most of my career I coded in C++ in competitive programming. In my job, I coded in several different languages: C++, Java, Python, JavaScript, and I'm pretty sure two, three more. So after a while, it becomes less and less important. So start with one. C++ and Java are the most common ones. Python is also used by few, but I would recommend just stick to C++ or Java. Solve about at least 20 or more problems to at least get a hand of like you understand the syntax. You have a basic understanding of the how the language works. Once you have enough confidence, then understanding basic data structures and algorithms is super important. Stacks, queues, trees, linked list graphs, these are the very basic data structures, which I guess is part of your curriculum already in second year or maybe first year. Is it in second year or first year right now?
Sir, it's mostly in second year or first year also.
Okay. Yeah, so just learn these. If you have already taken the course, then it's well and good. But understanding the different aspects of these data structures is super important. The aspects are like the time complexity, space complexity, and you should be confident enough to write a clean code for most of these. People generally learn stack, use all these pretty quickly because there are standard templates available. But if you move to things like linked lists or graphs, then things start to become difficult. So look at the codes from some of the programmers who are active on these competitive websites, especially for graphs, because represented graphs in easy way is actually nice while trying to solve problems on BFS and DFS. So the representation of graphs, especially in the adjacency list format, try to learn those things. Then it will be much easier for you to kind of get started with it. Basic concepts like time complexity, space complexity, understanding like how bad your code is key in order to improve it. So things like different notations of time complexities like O of n square. You should know the difference between them. Difference in the sense, so how much time your code is going to take, you should be able to guess roughly without even executing it on a machine. So based on the constraints and the algorithm that you are writing, you should roughly guess like how much time it takes. I recall from long back, like even one of the interview questions was very popular. Like how much time will it take for a 64-bit counter to overflow? So in these, people generally try to judge like if you have a good understanding, basic understanding of how much time machine takes, how many operations, addition operations happen in a single second, and based on that, if you can do a rough computation. So that's where it's important. Unless you know, like if your code is actually bad, you won't be able to improve it. Space complexity is also key. It's actually not very important most of the times in competitive programming, but it becomes important if you start appearing for interviews or even in the industries. So just ensure that you try to optimize for it, but it's not like most of the time it's not key when you are attempting the competitive programming problems. Then start with basic algorithms. Sorting is something which you get taught like very initially. Understand what's the difference between n log n versus n square algorithms. Some of them are deterministic. There are some which maintains the order. So all those concepts just try to understand. Then power exponentiation, like if you're computing a to power b, then this is also good. And understanding basic bits operations like shifts or ands or all these things are always good to know. In this stage, focus on the depth of the algorithms. Don't try to learn a lot of things, but whatever you are learning, just try to go deep in it. And I think now a lot of these websites even allows you to solve problems on specific topics. So if you are learning one algorithm, then take the problems for that topic and solve as many as you can. Any questions around it? I'm pretty sure you all must be very habitual in taking lectures and listening to them. So let's not make it like it. So if you have anything, just feel free to speak up. I think Ganesh is asking one question. So which all graph algo should we focus more on? And so Let's start with very easy ones. BFS and DFS are the key ones. Like you should be able to iterate. Uh, is it about tree or graph? Okay, graph. So you should be able to iterate the graph, uh, and both has their own advantages. So understand the applications of both. After that, move into the more fancier ones. There are a lot of shortest path algorithms. Uh, then comes these um, minimum spanning tree algorithms. After that, if you go more advanced, then computing the articulation points and bridges. All these have applications in real life as well as competitive programming. You can find a more comprehensive list in some blog or somewhere where all the algorithms are listed. But the important is to understand the basic structure of the graph. So any algorithm that is available on internet, you can able to relate to it. Should we note down each and every question in our notes? So Nikhil, do you want to clarify more on the on this question? Like what do you exactly mean? You can speak up. It's just unmute yourself. It's fine.
Sir, I just wanted to ask that which kind of question should we include in our notes?
Sorry, what kind of questions you mean?
Yes,
The
sir.
one the
Sir,
people ask.
we are beginners, so each and every
Mhm.
question seems like very important. We could not
Okay.
differentiate between important and uh,
So initially, like if everything is important, then keeping notes becomes hard as well. So just note down those, the ones that you're not able to solve, so that after some time you can revisit them and see if you're actually making progress while learning. When I started, Spoj was pretty popular and it was maintaining a to-do list, like the questions which you have submitted but are not accepted yet. So it was doing that job for me. So I was trying those questions after like 3 4 years, in fact. Then I found out there are so many silly errors that I made in my early days codes, which were easy to cut. So definitely store those problems which you are not able to solve. Which you're able to solve, it's fine. You can always find them in some different forms. Kanishk is also asking if articulation and bridges algos asked in interviews. Uh, Conceptually, it's good to know. I haven't seen them being asked very common, but if you are like really lucky or unlucky, then you might get asked such questions. But the problem is, if you know about some algorithms by name and don't know what they actually do, or at least the applications, then the problem what happens is if you get stuck in a problem, your mind thinks that this problem is from the topic which you don't know. Then it becomes problem. Even though the problem could be simple from a topic which you're already aware of, or some ad hoc algorithm which you can come up with if you think enough. But because there are few blind spots which you haven't covered yet, then it becomes hard to think. You always think, okay, this is from that topic and I cannot solve it. This was happening with me for a long time with MaxFlow. So any graph problem which I wasn't able to solve, my mind always says, okay, this might be MaxFlow. So cool, we can move if there are no questions. Then intermediate level. So if you already have a lot of coding handles which are more than your social media accounts, which happens with a lot of us, uh, you feel in one contest you feel that you are expert, you know everything. In next you feel you don't know anything, you're not able to solve a single problem. And your rating is around 17 1800s on most of the platforms. They follow similar rating trends. So that means you are intermediate. And the questions that always comes up in your mind is like how to improve. This is the time when you need to learn advanced algorithms. So earlier I said that focus on the depth of the algorithms. This is the time when you need to actually focus on the breadth of the algorithms and at least understand the applications of what different topics exist. Implementation wise, if you know, that's great. If you don't know, then there are enough libraries which allows you to use these in a black box. But at least understanding their application and when to use is very important. Especially max flows, suffix arrays, suffix automations are few of the things that directly comes to my mind. So there shouldn't be a single algorithm which you have heard multiple times in your contest and you don't know about what it does. So remove your blind spots from at this stage. Then trying out different flavors of problems is important. Like if you see, at least when I was solving top coder and code forces were most popular and they were providing very different kinds of problems. Like code forces were always code heavy, whereas top coder ones were mostly about finding the right algorithm. Then implementation wise, they were much more simpler. And in fact, like top coder problems were much more closer to interview problems as well. Like they require a thinking. Once you have the idea, then you can crack the problem. But getting to that initial idea, even for the simplest problems, was tricky. So try on different platforms. Don't just stick to one. So your thinking ability changes when you move from one to another. Upsolving is very important. So if you're not able to solve a problem, solve few problems in a contest, or somebody asks you, then upsolving them is very important. And solve a lot of problems of varied difficulty. Try out the hard ones. See what is the difference between a hard problem and an intermediate problem. Sometimes hard problem could just be asking a lot of easy ones and a code implementation heavy. So understanding all those things, getting a gist of it is important. Are there any questions around it?
No, sir, you can move on.
Cool. And let's talk about different contests. How many people actively participates in short contest here? Just write +1 into the chat if you already do. Okay, I could see quite a few people. So I can share my experience, like how I used to tackle these short contests. As you might have seen, like the accuracy is much more important in short contests, especially the individual ones, uh, even more than speed. Because if something is wrong, there are heavy penalties. Sometimes there are system test concepts. So you solve three problems, sometimes you end up with zero corrects, and that becomes a sad situation. So accuracy is more important there, I feel. When you're giving these short contests, ensure you have a atmosphere with no distractions. In hostel, it might be hard. In home, it might be a little easier. But to ensure like the accuracy, it becomes important that you're focused when you are writing the code. So sometimes you have the entire algorithm, but you miss some steps like do silly errors like overflows or some divide by zero stuff, like miss some very easy edge cases which you shouldn't have missed. So that's why it's important that you are in a silence when you are attempting those. Uh, like when I was really trying hard to perform well, then always like just before the contest, I was trying some extremely easy problems to warm up the mind. Sometimes even I was solving division 2A, which was the just the easiest. So don't take up any hard problem. Like if you actually try out hard problem just before the contest and you're not able to solve it, then your mind just keep on thinking about it. So pick something very easy, just code it up so you get into the rhythm. That actually helps in solving the easiest ones very fast. Automate your repeated tasks. Repeated tasks, like if you're writing the same code again and again. People include the lot of macros in their libraries, but that's very basic stuff. After that, you can improve it or extend it to write all the algorithms in your library, and ensure these library are well tested and maintained by you. So use them a lot of times before going to any important contest. Like I have learned these lessons hard way as well, where some of my libraries were not tested and we figured out in an important contest some bugs. Especially that happened in one of my heavy light decomposition library, which is used for trees. So even some of these the hard algorithms you can actually a lot of people put, but sometimes easy things which you always do a lot of times, like I'm just computing factorials. So all those things, if you put them in your library in behind a functions, like at least the Sublime text provides this functionality of snippets where you can type a single keyword, press tab, and everything is the code is just pulled in right away. So all these editors provide these functionalities. You put all the common ones, a simple DFS, BFS also you can put in your library so that it can save you some time. Most time you want to spend while thinking about the problem and not while coding. So try to minimize the coding time as much as you can. Then upsolving it's always important. Upsolving in any contest, not just short. So at least the easiest of the unsolved problems. Let's say there are 5 problems in a contest and you're able to solve 2. Then the third problem is something which you should try even without looking at the editorial. Like if you cannot solve that problem in infinite time, then solving it in within the bounds of the contest timings is anyway going to be impossible. So try that, and if you cannot solve after that, try with hints. Like first look at the topic which belongs to that particular problem. If you still cannot solve it, then start reading some 1 or 2 lines of the editorials. At least on Codeforces, the entire editorial most of the time feels like a hint only. So just read through it and then try out the problem. If you still cannot solve it, then look up at the code of the some of the accepted ones, and that's your final ultimate way. Like if there is nobody who can actually come and explain to you the solution, then reading code, going line by line, is your like only way left. So try that, and then try to understand the editorials. If you cannot understand it once, it's totally fine. Sometimes it takes repeated tries. I still recall when I was learning the binary index tree, at first it's almost impossible to understand it. So I spent like multiple days, multiple iterations reading the same article again and again to actually get a feeling of that it's actually a tree, which feels odd at first. Same is with editorials, especially if you are uh, reading editorials of hard problems involving complex mathematical concepts, then it can take multiple weeks in order to understand it. But once you understand it, you actually can solve a lot of problems, and it gives you a lot of confidence also. Then long contests. These are personally my favorite ones. So these helps in building your knowledge base because the problems are there for multiple days. You can try out your all your ideas. In lots of Google search you can do. Sometimes you get wrong hints from searching and you implement something which is completely way off the problem. Even though it won't give you a green tick, but at least it helps you in learning new things. If you are able to solve a problem right away, then that's not the right problem you are solving. So it's a good thing if you're not able to solve some problems, they will ensure that you learn something new. For hardest of the problems, read a lot of papers, read similar problems on other platforms if you can find. I recall at some point in CodeChef long contest, one of the popular topic was FFT, its different variations. So learning those from other problems, I know I did it few times. So that was important. Like that's how I approached them. But a lot of times these problems were coming from some papers. So you need to do the right search, and if you have the paper, then you can try to grasp these new concepts and implement those. Don't give up. Uh, Even if it's a hard problem, just try it for some time. Even if you cannot solve it, then once you see the editorial, it will be much easier for you to understand it. So trying is important. I'm pretty sure that one day you will be able to crack all of them. And obviously, no cheating. I know long contests are most tempting to cheat. A lot of people try things, but it's not going to help. Like these ratings and all are of no use if you don't have the actual knowledge. It also helps in actually building some of the debugging things like a code snippet. If you see on the right side of the slide deck, so it's the code which I wrote at least 7 8 years back. I used to call it magic script at that time. So what it does is it's generally just basically first program that I'm compiling there. It's a test case generator which generates a random test case always. Then my actual solution is there. After that, I wrote a brute force code, and this brute force code is working on some set of test cases at least, and I'm generating only those test cases where my brute force can actually finish within time. Next line is doing nothing but comparing the outputs of both the codes. So this script just keep on learning iteratively, and whenever it finds a defect, just breaks. It's a very simple script. But I found this very handy in a lot of long contests, sometime in shorts as well, when I really don't understand like why my code is wrong, why is it failing. Then I quickly write a brute force code and a test case generator. I mean, you can obviously see there is a cost associated with writing quickly test case generator and brute force. That's why it's always I'm in a dilemma whether to use it in short contests or not. But in long, it's super good. Then there is a third category of contexts which are heuristic based. Sometimes you have seen this problem in the CodeChef long as well, like the challenge based problem, which is of partial points. That's where all your creativity comes in. It gives a good glimpse of what open-ended problems look like, which is sometimes the case is industry as well. Like these days, the projects which I'm currently working on are kind of very open-ended. So you just try to find the best optimal solution, which is good enough. And at some point, even in Google interviews, there was a one round dedicated to open-ended problem. I don't think that's the case anymore, but I'm a little outdated on the interview section as well. So in those, the people see like what's your different creative solution that comes to your mind, and whether you understand the limitations of those. Like sometimes the solution will just work for small constraints. Sometimes it works for a specific type of constraints. Like if it's a tree problem, then very specific type of trees only, then your solution will work. So there's actually help you expand your thought process. You think about different things. You mold your test case, or you mold the problem for to fit your solution, which is like a very different way of thinking about it. So I personally like these problems a lot, though I couldn't able to try them a lot. Maybe someday I will give it one more shot. But yeah, these are nice. Then obviously we have interview problems. These are relatively simpler if you are active competitive programmers. There is a myth that companies like Google, Microsoft, Amazon, they ask hard problems, but generally those are fairly simple. Fairly simple meaning, if you want me to correlate, then division to C, B, C types for Codeforces, that's the difficulty level generally. Like the set of problems or the set of topics which are involved is also fairly limited. I just listed few which came to my mind. Like I haven't spent a lot of thought in preparing these slides, so don't assume that that's the entire list. But very common topics are generally asked in interviews. What they really focus on, like sometimes I heard people say that they are able to solve problems, but they are still not get selected in the interview. In there, the focus is slightly different from CP. So the problem requires neat thinking and solutions. It requires proper handling of edge cases because there is any live system which is telling you whether your code is correct or not. And interviewers, when they give simple problems, they are always looking to find reasons to not select you. And if you are missing edge cases, then it's a very negative signal. Sometimes, if the problem is hard, then interviewer tells you that, okay, you are missing some edge cases and we want you to find them. In that case, they expect that you spend some time, you find the faults in the code. And if you do that, then it's a good thing. The other aspects which interview problems generally focuses on is the code clarity. Your code should be well indented and there should be good enough logical blocks. Like if you are computing something, then put them in a separate function and call them in your code. Obviously, there should be more clarity in terms of how you name your variables and functions. In competitive programming, A is your favorite name and I is your favorite iterator. So try not to do it in an interview problem. Then memory usage, which I said earlier in CP, it's not so important, but in interview problems, it becomes more important. Like they focus on these very small aspects, even though in industry, like memory is considered to be the cheapest thing, but still for some reason, interviewers tend to like optimizations around memory. So focus on that. And generally in interviews, the problems, or at least in Google, the problems have follow-ups. They ask you one question. If you give solution, they change, tweak it a little bit or extend it. And they try to see like if your solution is scalable enough, which can be applied to this new problem or not. It's fine if it's not, but you have to come up with the next version of the solution which fits in the new use case. So any questions around any of these slides? Okay, that's an interesting one. How to manage CP when mid-sem and sem exams approach? Just leave one. I mean, for mid-sem and sem exams, it depends like how much pointer or whatever it is called grade points you want to maintain. That's not your highest priority, then it will just take a week where you have to pause your competitive programming dreams.
Sir, like in general, how to approach a problem creatively? Like, since we are from a technical background, our creative and art standards, like it fatigues or end at one point.
So, are you referring to this competitive programming
Yes,
problems
sir.
itself?
In context of competitive programming or coding in general.
So, obviously, depth and breadth both are important once you tend to apply a lot of different things. And that's where the long contest comes in super handy. So like in short contest, generally you just try to optimize for time, whatever the first thing comes up to your mind, you implement it most of the times. But if you are trying out the heuristic problems or the long contest problems where the solution is not clear initially, that's where you apply most of your creativity. Like, um I recall like once you become comfortable with the normal problems, we had few discussions around problems like if you can find max in a range or min in a range. using binary index trees. When you think about the solutions for those, then it like improves your creativity. I would say just give it a shot on the heuristic problems. That is the best way to apply all your creativity. Then read the solutions from the top programmers. Even in CodeChef itself, I have seen people writing more than 2,000 lines of codes in that challenge problem. Basically, try out different solutions for different test case generation techniques. So once you reach to that level, then you will feel that you are much more creative in coming up with solutions. And that's how the generally the research mindset also operates. Like if after the college you want to work in a research profile or a data analyst, then these kind of things is going to help you.
Okay, sir.
Okay, there is one more questions. We are second year students and have to sit for internship next year, and we are at beginning stage of CP. So should we focus more on CP or trying to solve DSC problems on lead code like platforms? I would say highly no for problems which are focused on interviews at this stage. Just try it out in the very end. Like at this point, you want to increase your thinking ability. So stretch as much as possible. Try to challenge your mind as much as possible. Try out the hard problems. It's fine if you can't solve them, but at least you will know like what's the heavy weight look like if you try to lift it. So in second year, third year, focus mostly on the hard problems which are part of CP. After that, once the your internship interviews approaches, when it's actually very near, you can selectively solve problems for those companies. Like getting job is actually not hard. You are in a college where there will be ample amount of opportunities, and there are so many good companies. Like it's not just single one where you have to go. So one or the other, you will anyway will be settled. Like you can look at the historical data. Like every year, people go and do these. So restricting yourself in terms of learning is not a good idea at this stage. If you actually can just unmute and speak, it will make it faster, but I can read this new question also. How to always think of optimized solution, like we are able to solve most problems, but not with a great time complexity. So that's a very good question. So it's the actually you are getting the first step right. So whenever you are trying out new problem, it's very important that you have some solution. Sometimes it happens you cannot even think about a single solution, whether optimized or unoptimized. So start with the bad solution, then try to build a journey from it, like how to optimize. Is it like some subcomponent of the algorithm which requires replacing it with something more efficient? Generally, that happens by replacing it with a data structure, not mostly an algorithm. So that's the right first step. It won't happen for too long. Like in initial stage, this happens to every other problem. Like you are trying out, you have a solution, but it won't work. It's n square where n log n is expected, all those things. But there are limited number of things which you will face while trying these out. So try out for few, then see the editorials. What's that one important piece that you are missing from your algorithm? Like if there is some unknown fancy algorithm which you never heard of, then it's almost impossible to come up with that in the real contest. Though a lot of times, like sometimes it's just replaced with things like segment trees and all, where one unoptimized part is then done efficiently. In other cases, I've also seen the brute force is optimized via memoization or dynamic programming. So just see these patterns. There might be hardly some 8 to 10 based on different topics. Once you know them, then it will be much easier for you to approach. We can move on to the last slide. Then we can focus just on question answers. So team contests. I'm pretty sure some of you must be focusing on ACM ICPC or wants to go to World Final someday. So this is the largest team contest. Lot of universities across the globe participate in it. It contains a team of three, and I think from every college, mostly one team goes into India regionals where they get selected to finals, and around some 7, 8 teams go to world finals. So the journey is quite nice and it's a very prestigious contest, though it requires different dynamics because three people are involved in a team. So approaching those is also a very important thing. The individual skills matter, but if you work like a team, then it can take you much farther. So different stages of the contest requires different kind of thinking. Like if you are part of qualifiers, then generally you want to solve some certain amount of problems. Being in the top is not necessary. In there, it becomes important that you solve the problems which are supposed to be solved by your team. Some of the common mistakes that people make is like they put the smartest guy in the team on the hardest problem and allocate in such a fashion. What happens is by the end of the contest, none of the problems are solved because you have allocated the heavier problems to your teammates. So it's important that you at least solve the easier problems very fast. Uh, Solving faster and accurately is more important than solving some of the really hard ones because generally the score distribution is same for each problem. So as fast as you solve them, it provides a very good chance that you are in the top X threshold, like whichever is needed for the next stage. And when somebody is coding, just ensure one of the teammate is actually looking at the code so you are not making any silly errors. And that's what you want to avoid in the initial stage. Then finals requires a completely different preparation. There you have a single computer, you don't have access to internet, and you need to write the entire code of your own. Like the libraries, even if you are taking those, won't be available in the computer directly. Instead, you can take the printouts. So just prepare for that. Compile a good library which is well understood by your entire team and not just by you. So anyone who is coding them, they can type them fast enough. The breadth of topics is more key. So if there are like in ACM ICPC problem set, generally all topics problems are there. Like people try to focus that everything is covered, which involves some of not so fascinating topics like geometry. But sometimes what happens is the problem is pretty straightforward. It's just you don't have the right library. Like if I talk about very simple things, like finding the angle between the two vectors, everyone kind of knows even from their 12th class. But when you actually try to code them, then sometimes these things becomes complicated. Or just sorting the points with the angle. So these are very basic things. You can come up with the algorithms most of the times, but coding them becomes tricky. So focus some time on building the breadth of these topics, include these common algorithms in your library, and then tackle these contests. Initial phase of the contest, just try to solve very fast and see how many you can solve. Then after that, it becomes the top teams are defined by the number of problems they solve. So try to work on hard problems differently, find clues, like there might be some few hints which can actually help you in order to tackle that. So actually, that's all from my side. It's been a very silent audience. Do you have any more questions?
Hello.
Yeah, Vishal.
Yeah. So good evening, sir. So I have a question that
how should we approach to building an optimized solution? Like we have a solution for a problem, and what should be our process to build a optimized solution?
So building optimized solution from a unoptimized one requires more depth or more understanding of different algorithms and data structures. Generally, this happens if you don't have enough knowledge or you don't know few of these algorithms, like I talked earlier. So in that case, if such a problem is part of short contest, then the good thing is you will get to know the solution very quickly in next 2 hours or so. So try it out and see which component is unoptimized, which you should have optimized by applying certain algorithm. Like without knowledge, it's very hard to come up with the entire solution yourself. Though it's the very good first step that you at least have some solution. Then building on top of it is a much simpler problem once you know enough algorithms. I would say read a lot more.
Okay, thank you, sir.
Any problem is click, but it's not implemented. Yeah, that also happens. Like you know the data structure, especially if it's a complicated version of trees. Things like centroid decomposition or just heavy light decomposition on trees. Sometimes you know if you have tried few of the problems, but implementing them in a short duration of time becomes very hard. In that case, also just try to implement it a couple of times. After that, it will be easier. Like I'm pretty sure, like most of you know, like what to do. I can just give you a session. Yeah, I also did few things which help. So if you have any doubts regarding that there are certain things you're trying out, whether that will help or not, you can feel free to ask.
Sir, in general, like how much time we should denote to a problem before looking up for a solution?
That's a very common question a lot of people ask. So if it's a problem from a short context, then I would generally recommend like look up for hints step by step instead of looking at the full solution. First, look at the topic, spend 1 hour or so, full 1 hour or so, focused, just trying to see if that solution fits or if you can come up with a solution using the topic. If you still cannot, then read a little bit about the solution. If the editorial is super detailed, then at least read the first initial portion of it and then retry the problem again. So try it in steps. But if you have spent a couple of hours on it and you're still not able to solve it, then I would say that look for the solution. Though these are for the short contests, for long ones, those requires much more effort. So in long contests, you can try out the same problem for like some 4 5 days, and then also you won't get. But like there are enough problems on internet which do not have any solution anywhere. So if the solution is available, then trying out for few hours and looking for a is not a bad idea. But generally, like if you are doing a focused practice or more organized way, like at some point I was targeting to be a red on top coder. In those days, I maintained a Google spreadsheet. I was solving a lot of Div 1 500 problems. And any problem which I was not able to solve, I was writing notes. Like, what is the exact reason behind I'm not able to solve it? Is it a new algorithm or is it something repeated and I still cannot able to solve it? So these notes you can revisit after a week, and it ensures that the new things at least that you were missing in the problems, you able to grasp them in a better way.
Okay, sir.
So just writing one two liners, just what's the reason of you not able to solve is good enough. It recaps you when you look at it again.
Yes, sir. Are we done with the doubts? Like, so I guess there aren't any more doubts. So like, now I would like to thank Akashdeep sir for taking this wonderful session. Thank you all for joining in. Now please feel to leave.
Yeah, and if you have any more questions, then you can just drop me an email. I'll try to respond in there. I can also type in my email in case somebody needs it.
Something about lead code.
Sure, sir. Go ahead.
Hello.
Hello? Yeah, yes,
Sir,
yes.
can I ask something about lead code problems?
What do you want to ask?
Sir, actually, like if I'm going to try some array questions and I check the question tags, there are multiple tags like some question have DP and backtracking also that I haven't learned yet. So should I try those problems now or not?
Which year are you in, like, in your
Second,
college? Second year, I would say that don't focus a lot on lead code. They are very restrictive or provides you only very specific kind of knowledge. But still, if you want to solve lead code problems, then take one topic, understand it properly, solve from easy to medium problems, then visit the another topic. The hard problems generally require knowledge of several different topics, so don't try that initially. Once you
sir,
become
the easy ones
comfortable,
also have
hmm?
multiple tags.
Sorry, the medium ones,
Sir, easy ones also have multiple tags.
you can ignore those problems which have multiple tags and the questions which you don't know. Just restrict your learning initially on very specific few topics.
Okay, sir.
Sir, could you please suggest some platform which to practice
For beginners,
uh, beginners to intermediate?
I listed few like if you know algorithms good enough, then try out ad coder problems. They require a lot of thinking. So I haven't gave a lot of contest on it, but I personally like it. Even the old top coder problems were very popular for DP. Like in initial SRMs, there were you can find if you try to search on Google, there will be a list of problems which are on dynamic programming on top coder, and those are really really good ones. After that, if you are a very if you are just starting, then solving on any platform is fine. Like there are a lot of very easy problems. If you are getting familiar with the syntax, then just start with Codeforces, the easiest ones. Then move on to the long contests so that you have enough time. You don't feel that pressure of the short contest. Sometimes that adds to the anxiety as well. The pressure of seeing the rank list directly. So that's not everyone not don't like that. So solve problems with giving yourself enough amount of time.
Thank you, sir.
So, what are some good resources to learn DSA?
Uh, uh, Generally, I find blogs the best, but it's not single source which gives you the best result. So there are a lot of popular blogs, but I am not able to understand them properly. So everyone has their own flavor of learning. I would say just do Google search on the topic which you want to learn. The important is to have a list of topics which exist. And there are two ways, obviously, like you can look for the syllabus. I think there are few blogs which provide the entire list of topics. And the other is you just start solving problems, and whenever you're stuck, you can look at like which topic does it belong to. I personally preferred the other way, like I can just start the problem and see like which topic it belongs to, then learn about it. Because when I have some goal in my mind, then learning a new algorithm becomes much more easier. And the good source is just search and see whichever the first result is. The Corban book is nice, but books are generally hard to read. Like there is so much of content in there, and it can sometimes be demotivating when the book size is too big.
Thank you, sir.
Cool. Anybody? Anything else?
I guess no.
Cool then.
Yes, it was a great session.
That's good to know. I would have loved if it would be a lot more interactive. But I can sense that a lot of people are still new to all this. So
Yes, sir.
just don't get demotivated. It's a lot of fun. Journey is much more fun than the final end goal. So enjoy that. If you are not enjoying your academics, then at least this is one thing which you can where you can try out your hands and build a different kind of expertise and still helping you in getting a job and even in the industry work. Cool then. I can drop off if there is nothing else.
Yes, sir.
Thank
Cool.
you, sir.
All right. Thank you. Bye bye.